Okay, so another one of these intermittent videos, recordings that I'm doing about critical thinking and critical analysis, which should help people who are trying to evaluate psychology papers. One of the things that I want to talk about today, and I may go on to talk about this subsequently, is the use of metaphor in trying to think about papers. And what I mean by metaphor, more analogy is probably a better word. Trying to take a particular design that somebody's done or a particular set of results that people have done and change some of the variables, okay, so that it somehow becomes simpler. This is all fairly abstract, so let me try and give you an example which actually happened this morning when I was talking to a student who was trying to critically evaluate a psychology paper. The paper was trying to demonstrate, or was trying to ask the question, as to whether we have an innate ability to detect predators. It was a paper from evolutionary psychology, so what they were trying to argue was that humans have been around for many millions of years, and we've been in the presence of various predators which potentially could eat us, so it would make sense for evolution to have wired into us some ability to detect predators which might potentially eat us. And they picked lions in particular, because lions, I guess, in many respects are prototypical predator of humans, at least in our minds anyway, even though lions don't now result in many deaths. Because our ancestors evolved on the plains of Africa, it could be said that, argued that in the past, lions were a significant predator of humans. So they're saying, well, maybe we've got some ability to detect predators such as lions. So to do this, they presented participants, these were adult participants, with a task in which they were attached to an eye tracker, and they were presented with a bunch of stimuli, so photographs, and these photographs were either of predators such as lions, in fact they were exclusively lions, or non-predators, and these were, and for the sake of this experiment, were impala. And impala is just basically a kind of antelope which eats grass, so it's not something which would be dangerous to humans. So participants were seated in front of a screen, a blank screen, and they were told to fixate on a particular point on the screen, like a little dot, right in the middle of everything, and then they were presented with a bunch of photographs around this array, and they were told that the task was a predator identification task. What the results showed is that people were faster in this condition at fixating on a lion than they were fixating on an impala, this antelope kind of thing. And they concluded that the fact that people were faster at fixating on a lion, they could find a lion, they could move their eyes faster towards a lion than the other animals, that this meant that there was some evolved, innate predator detector that we have somewhere in our brains. Now we can raise all kinds of issues with that. For example, first of all, if we're making an argument that anything is innate, we need to really try and test whether this happens in very young children, because it could possibly be that we've simply learned the ability to detect lions as predators. Putting that aside, but that is an important issue, there was another problem with the experiment, which I arrived at, I came to this conclusion by doing one of these simple analogies. So basically, remember what they found? They found that people are faster at fixating upon lions when in a predator detection task than when in a different kind of task, okay, a condition. And they're claiming that this result shows that people have some innate predator detection task. So just have a couple of seconds to think about that and see if you can think of any problems with this, and I'll try and explain my problem with this, which I arrived at by a simple analogy. So in order to do this, let's listen to a little bit of jazz while we think. Okay, so let's turn the jazz off. And let's try and think about the analogy. So basically what I'm saying when I did an analogy here is I replaced some of the variables with different variables. So rather than saying we're in a predator detection task, let's just say we're in a furniture detection task. It's ridiculous, but I sometimes think the more ridiculous the analogy can be, the better it is. As long as the analogy is good, then it can really help to think and get to grips with what a study's doing about. So rather than the predator detection task, we have a furniture detection task. And our example of a piece of furniture is a wardrobe. So lion equals wardrobe, predator equals furniture. Yeah. So Imagine we present people in a similar experiment. They sit down in front of a screen, they've got an eye tracker on, fixate on a point. We then present them with pictures. Some of these pictures are of items of furniture, let's just say a wardrobe, and the other pictures are of non-furniture. Let's just say that they're cars, because cars are kind of relatively square things like wardrobes, in the same way that impalas are superficially shaped like lions, just to make the analogy kind of work. If we were to find that participants are faster in a furniture detection task at fixating upon a wardrobe than a car, would this necessarily lead us to the conclusion that people have an innate furniture detection software in our brains, some kind of algorithm which detects furniture? Of course it wouldn't. That would be ridiculous. But the analogy works perfectly. Furniture equals predator, wardrobe equals lion, and they're faster at fixating upon the furniture in this hypothetical analogous kind of furniture detection condition. So basically all it's showing really is that when you are priming people to think of a particular kind of thing, whether that be furniture or a lion, people are faster at recognising that. When you talk about predators versus lions versus non-predators, somehow it becomes harder to think about. Once you start to replace some of the variables with other variables, so long as the analogy works, suddenly the experiment seems obviously wrong. Of course we don't have furniture detection algorithms in our head. We don't have an innate ability to detect furniture or wardrobes, presumably because furniture and wardrobes are relatively recent inventions. So if you can find a good analogy like that by replacing some of the variables, think about it. If the thing suddenly starts to sound strange, and either your analogy is incorrect, and you need to think about that, or the experiment maybe is flawed. So, use analogies.